All right, so we want to simplify those. Square root of 17 does not simplify, so it's going to stay on the top. The bottom part, 72, that's what, 6 times 12? 3 and 2, 4 and 3, 2 and 2. So we got a pair of 2's and a pair of 3's. So that's going to be 6 radical 2, because there's that 2 left over right there. Okay. Now, what part is the problem in the denominator? That's square root of 2. The square root's the problem. If it was just 6 down there, not a problem. But it's a square root of 2. So we got to rationalize. So we multiply by the radical that's in the denominator. And then work it out. So that's going to be 17 times 2, 34. Over 6 times square root of 4. Square root of 4 is 2. 6 times 2 would be 12. And we've simplified that. Your square, anytime you rationalize, your square roots should go away in the denominator. And then you always look to see if you can simplify the numerator. It won't here because it's 17 times 2, and that doesn't break down any further. All right. A little further into simplifying some things that have radicals in the denominator. Those are the things that are making issue here, because 7 plus radical 2 is the same problem that we had when it was just a radical 2 in the denominator. It's still a decimal that keeps going forever, never terminates, never repeats. So we've got to do something to make that more rational, or make it rational in general, because it's not right now. The way you're going to do that is you're going to use what's called the conjugate. The conjugate is the other factor for a difference of squares. So if this were a difference of squares, one of the factors is 7 plus radical 2. The other factor is the conjugate, 7 minus radical 2. It just changes the sign in the middle. That's all it does. The conjugate changes the sign in the middle. The 3 is still up top. It ain't gone anywhere yet. We're just, the denominator is the one that causes the problem. So that's the one we're trying to fix. So we just use 7 minus radical 2. That's the conjugate of 7 plus radical 2. Conjugate, just change the sign in the middle. That's all you got to do. And then you're multiplying. Distributive property on top, 3 times 7, 21, minus 3 radical 2. And on the bottom, it's distributive property twice. 7 times 7 is 49. 7 times negative square root of 2 would be negative 7 square root of 2. And then plus square root of 2, so plus 7 square root of 2 minus the square root of 4. What happens to those middle pieces that have the square roots in them? They cancel each other out. They go away. What do we know the square root of 4 is? We know that that's 2. So 49 minus 2 would be 47. And now we have something that does not have a square root in the denominator. And that's the important part here. We're trying to get rid of that. M. Let's say we had 4 over 5 minus radical 3. So we have addition or subtraction in the denominator with a radical. So we're going to use the what? Conjugate. And the conjugate of 5 minus radical 3 would be, 5 plus radical 3. Just change the sign in the middle. Distribute on the top. 4 times 5 is 20. 4 radical 3. On the bottom, we know the parts with the square roots are going to cancel out. So we can take a shortcut here and say 5 times 5 is 25. Minus square root of 3 times square root of 3 is square root of, try again, 9. 3 times 3 is 9. And we know the square root of 9 is 3. So we end up with 25 minus 3 on the bottom, which is 22. Now we look at it and see if we can simplify it. We didn't do that on the first one because we knew 47 is a prime number, 21 and 3 is prime, 21 is not, but nothing would go into all of those. Here, we look at those three numbers that are out front, 24, and then the 22 that's on the bottom. What do we know about all those numbers? They can be simplified by dividing by what? 2. 2 goes into everybody, divide everybody by 2, except for the part that's inside the radical. And there we've simplified that fraction and got the radical out of the denominator. And that's the key. All right. So we've seen rationalizing when there's not addition and subtraction. Here's rationalizing when there is addition and subtraction in the denominator. So keep those in mind. Definitely keep those. Let's get to the actual what the lesson is about today, and that's solving. Solve by square roots. So we're going to use those skills to solve some quadratics. Not every quadratic can be solved by square roots right out of the box. The ones we're going to see today can. As we go later, I think Monday of next week, I think is the right day. We'll see some that can't be done this way right out of the box, but we can do something to them to make it happen. So we're going to solve by square roots. Let's start with this one. X squared equals 49. So something similar to that first example N here. Here we have x squared by itself equal to a number. That's the light bulb that says, hey, solve this by square roots because it's quick and easy. If I take the square root of both sides, what's the square root of 49? Not just 7, but plus or minus 7. Because negative 7 times negative 7 is also positive 49. So we can get, two different answers here. It's a square x. So that should mean you get two answers. All those factoring problems we did last week had two answers, right? Some of them were the same answer twice, and that happens, but it was two answers because it was x squared. We got x squared here. We should have two answers. That plus or minus is where those two answers come from. So anytime you take the square root of a number when you're solving, you've got to do the plus or minus in front of it. Here's one that's kind of similar, but it needs something done to it first. If we're going to solve it by square roots, what do we want by itself? The x squared, right? If we were going to do factoring, it's in the right mode right here. Remember, factoring got to get equal to 0. If we're solving by square roots, we want x squared by itself. So we're going to move that 24 by doing what? Adding it to the other side. And now I can take the square roots. Plus or minus on the side with a number. And we're going to break down. 24 doesn't have a nice square root, right? If it was 25, yeah, it's plus or minus 5, but it's 24. So we're going to break down that 24 the same way we just talked about, simplifying. So 24, 12 and 2, 4 and 3, 2 and 2, and I put my x equals a little close. So I've got a pair of 2's, and then what left on the inside? 3 and 2 together would be 6. Plus or minus 2 radical 6. That's the exact solution for that. And how would we get a decimal equivalent to that? Or decimal approximation of that? Type it in your calculator. 2 square root of 6 or square root of 24. It's going to be the same number. So if you needed a decimal approximation, it's just a calculator punch away. We're going for the exact solutions here because that's what we want. But when we adapt this to graphing in a week, we're going to need the decimal too. So because who knows where 2 radical 6 is on the number line? Off the top of my head, I can tell you close to where it's at, but I don't know exactly where it's at. But if I got the decimal, I could tell you exactly where it's at. So that's where that'll come into play, the decimal part. We're going to get the exact solutions today, though. Example P, 5x squared equals 80. What needs to be done to this one? Yeah, divide by 5 to get that x squared by itself. B. 16. Oh, that's nice because the square root of 16 is just 4, plus or minus 4. Nice answers on that one. Did awesome. Thanks for letting me know. I'm working on it. Technology is not my friend today. Doesn't seem to be working well. Well, shoot. We still got plenty of time. We don't have that many left. Don't worry. Apple TV. Fine. There it is. All right. And I just tapped in the password. There it goes. All right. So plus or minus 4 on example P. Example Q. X squared plus 7 equals 19. So here we have a number on the other side, and we got x squared plus 7 on the left side. What should we do? Subtract 7 first. That'd be 12. Can we take the square root now? Yeah, and plus or minus, and then 12, not a nice square root. So I'm going to break 12 down. 6 and 2, 3 and 2. There's a pair of 2's with a 3 left over. So that's 2 radical 3. Simplifying that square root to get those answers there. For R. Let's throw a fraction in there. 2/3 x squared equals 17. That's fun when that doesn't simplify very, very nicely. How do we get rid of that fraction? Multiply by the reciprocal, 3/2. Okay, 17/1. We would look to simplify that cross cancel if we could. It doesn't, so 17 times 3, 51. 2 times 1 is 2. We get x squared is equal to that ugly fraction. But we did do some practice on simplifying square roots of fractions. So we're going to do plus or minus the square root of that fraction. And we know that that's really the square root of 51 over the square root of 2. And we try to simplify those. What do we know about It's not showing up. What do we know about the square root of 51? What numbers does 51 break down to be? We got it from 17 times 3, but does 17 or 3 break down any further?
No.
No, so we know the square root of 51 is not going to simplify. We know the square root of 2 is not going to simplify. But we don't want to leave a square root in the denominator, so what do? Multiply by, not just 2, but the square root of 2 over the square root of 2. And that's going to give us the square root of 102 over 2. So x equals plus or minus the square root of 102 over 2. There's an answer there. You could break down 102. I mean, it's still 51 and 2. It's not gonna simplify any there. Let's look at one that looks a little different in the fact that the x is not squared. It's x plus 4 that's squared. Getting ahead of myself. X plus 4, quantity squared, is equal to 36. The key here is that is the square part by itself? No. It's not? What's squared? The parentheses. Is that parentheses by itself? There's nothing else on that side? No, there's nothing else on that side. So once I have the squared piece by itself, I can take the square root of both sides. And it's going to get rid of the squared on the parentheses. Okay? That's far superior to multiplying that out and then having to get x squared by itself. Because if you multiply x plus 4 times x plus 4, you get x squared plus 8x plus 16. And you got a plain x in there, and that opens up a whole another game of how to solve these. But because it's squared, I can take the square root of both sides. And the left side, the squared goes away, and it's just x plus 4. And on the right side, what's plus or minus the square root of 36 would be plus or minus 6, right? So I've got two equations. I've got x plus 4 equal to positive 6, and I've got x plus 4 equal to negative 6. I've got two equations. That's going to give me two answers because that's what I should get with an x squared problem or a problem that's got squares in it. So I'm going to subtract 4. X is 2. Subtract 4. Negative 10. Out of that. Okay. So the parentheses being squared, you can get that by itself, then you can take square roots. That's the key. A couple more examples here, and we'll be done for today. Hope you guys are checking out on it. So this one's a similar problem to this. That's why I wrote it beside it there, so we can look at this and see what's different. It's got that minus 6 over there. Can I get rid of it?
Yeah.
How? Add 6 both sides. So that's going to be 28. Now, what do? I can take the square roots out. I can get rid of that squared on the parentheses. And I'm going to break down 28. So I'm over here on some scratch paper. It's 4 and 7. I know 4 is 2 and 2, so that's 2 radical 7. Because it's a radical, that means, I really can't put it together with this 7 that's over here on the left. So my move would be to subtract 7 to get x by itself. This is how I want you to write that answer. Negative 7 plus or minus 2 radical 7. That's two answers. Negative 7 plus 2 radical 7 is one answer. Negative 7 minus 2 radical 7 is the second answer. But still two answers out of that. All right. As tough as they get, 3 parentheses x minus 2 squared plus 8 equals 57. Pretty strange problem, but doable. What do we do first? Yeah, move the 8. It's 3. X minus 2 squared equals what? 49. That's a good number. But I got to divide by 3 first. So that makes it not as good a number. Still a decent number. Does 3 go into 49? Yeah, so it doesn't go evenly. So we're going to leave it that improper fraction there, 49 over 3. If that would reduce, if it were like, 39 over 3 or something like that, it goes into it evenly, or if it were like, 18 over 12, you would reduce that fraction if at all possible. Just like any problem with a fraction in it. Try to reduce those fractions if they will. If they won't, then just leave them there. And then what's the next step in this problem? You got to take the square root of both sides. Side with the number gets the plus or minus. That's a fraction inside of a square root. So we've talked about that today. We're going to simplify that as much as we can. We know that the square root of 49 is what? 7. So that's really 7 over the square root of 3. But what's the problem with that? Square root in the denominator. We got to get rid of it. How do we get rid of it? Yeah, there you go. Square root of 3 over square root of 3. So that's 7 square root of 3 over square root of 9, which is 3. So we have x minus 2 equals plus or minus 7 radical 3 over 3. How do we get x by itself? Add 2. Can you combine 2 with the 7 radical 3 over 3? No, they're not like terms. You just can't put them together. You could, if we needed the decimal equivalent here, we could, but we're just going to write it like this. You got 2 answers, 2 plus 7 radical 3 over 3, and then 2 minus 7 radical 3 over 3. Once you get there, you got it done. So that kind of takes us through everything that could possibly happen to you on a problem in this particular section. Now, on page 269, we're going to do these problems to get some practice at that, and then we'll pick up complex numbers over the next couple of, tomorrow's Wednesday, Thursday. We'll get complex numbers, which feeds right into this, and then we'll complete the square as well on Thursday, I believe, which gives us another way of solving quadratic equations. Okay, so that's our assignment. You got about 30 minutes left in class today if you want to get started on some of those. The first set, 3 through 18, is just the radical stuff, simplifying, rationalizing that stuff. And then 22 through 33 is actually the solving part. So if you want to start part of that today, you can, and be prepared for other stuff. Sorry. Yes. Yeah, just go this one down here. Folks that are missing a quiz or a test, we need to try to get that done tomorrow. Some of you have, you're a couple of tests behind. The quiz is behind. So if you're missing a test or a quiz, unless you were out all week last week or something like that. So I got mine, you want me to check the 3 tests. Leah, you want me to check the 3 tests. Gage is out, let me check the 3 tests. Hey.
Okay, so I don't have a lot to make for the first quiz and the second quiz, but I'm during skinny walk I have time, so you can come like all through this week come to during skinny walk and jam or
That's up to you. If you can, the thing is, your test you're not going to be able to finish in the skinny block time.
but the quizzes.
The quizzes you could, yes. Quizzes shouldn't be a problem to finish during skinny block. So that's fine. And let's see. Yeah, it should be fine.
Okay.
Yeah, this week just make sure you're ready before you come because I don't want you to have to.
Yeah.
All right. Mm-hmm.